on to more stuff in solving proportions and using proportions. So this is section 7.3. Here's the I can statement. I can solve part to part. So go ahead and put the word part right there. Part-to-part ratios and proportions. So as a warm-up activity, what we're going to do is we're going to use those rules and ideas that we came up with in that last section, that two-color chip activity, in order to fill these in. Now these may be problems that you did before, but they're good practice. So I'm going to use the idea of a scale factor because I think that's a really useful one. So what we're going to notice here is that we've got the reduced ratio here is 4 to 5. We're missing the yellow part and the red part, but we do have the whole part. We do have the total for the two of these. So what we're going to do is we're going to total the two of these. So 4 plus 9 equals, 4 plus 5 equals 9. And then we're going to think about what do we do to the 9 to make it a 27. So on this problem, the scale factor is actually going to be 3. We're going to multiply everything by 3. So if these add up to be 9, if we multiply by 3, we get 27. So we're going to multiply by 3 here. So if I do 4 times 3, I end up with 12. And if I do 5 times 3, I end up with, and I'm going to move that equals 9, I end up with 15. So let's just double check. We've got 12 and we've got 15. Those add up to be 27, so that part looks okay. And if I were to do 12 over 15, does that reduce to 4/5? It does, so those are equivalent fractions. Let's take a look at this one right here. We have the yellow part. The yellow part would be represented by this one right here. So I would times by, so let's stop and think about this. 2 times what would equal 80? That would be 40. So that means that the scale factor on this one is 40. So I'm going to put that right there. And actually I'm going to put a box around each one of these so I can kind of tell where they are. So we times by 40 to get 80. Let's times by 40. We get 120. 3 times 40 would be 120. So I got the 80 here, I got the 120 right here, and then if I add the two of those together, I end up with 200. So we've got that filled out. I do want to do one more double check. If I added these together, if I did 2 plus 3, it equals 5. And let's check and see, what is 5 times 40? It happens to be 200, so we're in good shape there. So this method works great with this scale factor thing. Again, we've got the 3600 right here. We've got the 7 and the 5. That's the reduced ratio. We've got to find these numbers right here. These are going to be pretty big because they add up to, there's 3600 chips here. So let's do the 5 plus 7. We end up with 12. 12 times what equals 3600? So let's do this. Let's divide both sides by 12. And let's see, 12 would go in here 3 times, so that would mean x is equal to 300. So I'm going to put a scale factor of 300 right here, put a box around that one, and I'm going to do 5 times 300. That's going to be 1500. And I'm going to, 7 times 300, that's going to be 2100. So if I had 1500 here and 2100 right here, if I add those together, I get 3600, and as you can tell right here, if I had 1500 over 2100, that would be equivalent to 5/7, so we're in good shape right there. Now, the stuff that we did here and the stuff that we did yesterday in the previous section, that's presented in a table, and that's hopefully not too bad to understand. I mean, we did a little bit of practice with that. Everything's nice, neat, and orderly. Everything is in the exact same order all the time. That makes it pretty easy, but when we've got a description about the numbers involved in a ratio, it can be a little more difficult. So here's what we're going to do on this problem. We're going to spend a couple days doing problems fairly similar to this. So here's example 1, and please make sure you follow the instructions. I've kind of set these up so it'll kind of step you through the way to think about these, and so you can kind of help put all the pieces together. So it says, please determine the scale factor. Put a box around it like we did up above as you try to solve each problem below. Remember, show your work, so you've got to show some work as you go through and do this. You may use tables to model your answers if that's helpful. So I've got a table over here that might be helpful, and I'll show you how you can use that. I'm not a huge fan of it, but you're welcome to use it if you want. And then it says read carefully and be sure to answer the questions in each problem. So we are going to have an actual kind of short phrase or short sentence answered each one of these. So it says a recipe calls for 3 parts sugar to 7 parts water. If we know we need 15 parts sugar, how many parts do we need altogether to make the whole recipe? Now here's the key here. We need to know how many parts we need all together to make the whole recipe. So we're going to be doing something like this. It's kind of like, here's the sugar, here's the water, and then there's the total number, the number of parts altogether, if you want to think of it that way. So 3 parts sugar to 7 parts water. So we're going to keep track of the parts and the whole on this one. So on this one, we're going to say that this is the sugar, and we're going to say that this is the water. So we're going to, instead of red and yellow chips, we're going to have sugar and water chips, if you want to think of it that way. So this is 3 to 7. Okay. Now, we know we need 15 parts sugar. So 15 parts of sugar. So we know that this is going to have to be a 15. So we're going to times by 5. And we're going to have to times that by 5. So that's going to be 35. Now, if you'll notice, that right there is the scale factor. So I'm going to put the scale factor of 5 in a box. And it says, we know we need 15 parts sugar, so we've got that part right there. How many do we have altogether? So the whole is altogether. Okay. And altogether we have, let's see, that would be 10 parts for one recipe, or according to this right here. And then notice that if we multiply these together, we end up with, let's see, if we times it by the scale factor, we end up with 50. And lo and behold, if we added these parts together, 13 plus 35 is equal to 50. All right. There we go. Okay, so we've got that. So there's the scale factor, and that's how many parts we'd need altogether. And then don't forget to answer the question. So we'd say 50 parts altogether. Okay, so I'm going to circle the answer. So a box around the scale factor, and then a circle around the answer. Now let me show you how you could use a table to figure this out. So we could keep track of the sugar and the water, and we could say, well, the ratio is 3 to 7. And what we could do is we could just kind of scale that up. So we could say, well, let's see, if I added another 3, this would be 6. And if I added another 7, this would be 14. It's basically like counting by 3s and counting by 14. So let's go ahead and count here. So this is 3, 6. Another 3 would be 9, 12, 15, 18, 21, 24. You don't have to go all the way. I mean, we already know what the answer is on this one. And then let's count by 7s on this one. 7, 14, 21, 28. Those multiplication tables really come in handy. 35, 42, 49. And then if we added those together to figure out what the whole was, this is only 10, this is 20, this is 30. Look at that nice pattern right there. This is 40, and this is 50. This right here is where our answer comes in. So there's the 15 parts of sugar, there's the 35 parts of water, and then there's the 50 parts altogether. Okay. Next one. Tony won first place and John won second place in the spelling contest. They shared the cash prize in a ratio of 8 to 5. Okay. So ratio of 8 to 5. So I'm going to move these over just a little bit, and I'm going to keep track of, Troy won first place, so he won more, so this is going to be John. And it says if John received 65, how much did Troy receive? So John received 65, so this is 65 right here. How much did Troy receive? So this is what we're after right there. That's what we want to know. Well, the scale factor right here, how would we go from 5 to 65? Well, we would times by 13. So we'll times by 13. So again, I'm going to put the scale factor in a box over here so I know what that is. And if I times by 13, let's see, 8 times 10 is 80. And then 8 times 3 is 24. So that would be 80. Whoops. 80 plus 24. And so we end up with 104. Okay. So $104 for, and that was a T, so that was Troy. $104 for Troy. So I'm going to go ahead and circle that right there. Now, on this particular one, we didn't have to keep track of what the whole was, but I do want you to notice that if you add these together, this is 13. Now, this is going to seem, this is just by coincidence, but if we times that by 13, 13 times 13 is 169. And check out what happens if you do 104 plus 65, you get 169. Okay, so we're in awesome shape there. Okay, now that's the right answer, but again, if you wanted to model this, you're welcome to do that. So we'd start off like this, 8 and 5, and again, this is Troy and this is John. So the ratio of Troy's winnings to John's winnings was 8 to 5, and then let's just count by each one of these. So count by 8, 16, 24, 32, 40, 48. Let's see, 56, 64, 72, 80. Well, so we've run into a bit of a problem here because this is a big enough number. We've got to have a longer list here. Now I'm just going to run through. I'm going to do 10, 15, 20, 25, 30, 35, 40, 45, 50. We'll keep going on this one. Let's see, 88. Let's see, 96 and 104. And then this would be 55, 60, and 65. So you'll notice that we get to the end right there. There's the 104 and the 65. So this is one reason why I don't like this. Depending on how big the ratios are and stuff like this, this can take a long time. It can be tedious. It is very clear what the answer is, but and how we get there, but it can be a little more difficult. So where does the scale factor come in on this? Well, let's count how many times we did this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, if we count that original one, if we count 1, yeah, it's 13 boxes. Let's see if that works up on this one right here. We figured out the scale factor was 5. 1, 2, 3, 4, 5. So it's the 5th box, 13th box on this one. So if you know the scale factor, as you're scaling that ratio up, then we're in good shape. Okay. All right. Let's run through and do just a couple more quick ones and we'll be done. It says Ed and Diana collected 85 bucks. Oh, one more thing I wanted to mention about this. Yeah, that whole thing right there. If they had said something like, how much did they win altogether? How much was the prize money or something like that? The prize money was $169 altogether. So keep stuff like that in mind. Okay, now let's take a look at this one. Just a couple more quick examples. Ed and Diana collected 85 bugs. They collected 85 bugs altogether. For every 5 bugs Ed collected, Diana collected 12. How many more did Diana collect than Ed? So notice in the question right here, it says, how many more did Diana collect than Ed? So here's what we're going to do. For every 5 bugs Ed collected, Diana collected 12. So 5 for Ed and Diana was 12. What that means is if we added those together, the whole part here would be 17. And it says Ed and Diana collected 85 bugs. That's all together. So 85 would go right here. So here's our comparison. Here's how we can figure out what the scale factor is. So 17 times what number equals 85? So I'm going to do 17 times x equals 85. We're going to divide by 17. We're going to get x equals 5. So the scale factor on this one is 5. So let's scale these up. Let's multiply each one of them by 5. So this would be 25 here. Multiply that by 5. You end up with 60. So this is what we're after right here. Now, the answer to the question, though, is how many more did Diana collect than Ed? So we'd have to do 60 minus 25, so we'd end up with 35. So we'd say Diana had 35 more. Diana had 35 more. Okay, so I've got a box around the scale factor, and then I've got the answer to the question that Diana had 35 more. Again, I'm going to run through and I'm going to go through and do this, but let's make a little prediction. The scale factor is 5, so I'm going to have to repeat this, or in other words, grow this, count by this ratio or this fraction or this numerator and denominator 5 times. So we're going to write down 5, 12. So let's do this. 10, 15, oops, almost skipped one, 20, 25, 30. Okay, so we should only have to go to the fifth one. Let's see, 12, 24, 36, 48, and 60. And there we go right there. If you add those together, you get 85, and that's what we're after. That's why this is the answer right there. Okay, for every 2 raffle tickets Derek sells, Rachel sells 7. If they sold 63 tickets total, how many did Rachel sell? This has an asterisk by it. Might be similar to one on your assignment. Maybe there's something difficult about this, but let's take a look. For every 2 raffle tickets Derek sold, Rachel sold 7. So we're going to do Derek is 2, Rachel is 7. There's that reduced ratio with the parts. If they sold 63 tickets total, okay, so we're going to do the same thing. The whole part of this ratio, they add up to 9, and it says they sold 63 altogether. So what's the scale factor? Well, the scale factor, what would we multiply 9 by to get 63? It would be 7, so we're going to times by 7. So that's going to make this 49. That's going to make that 14. Notice that they add up. And it says, how many did Rachel sell? Well, that means Rachel sold 49. Let's do the scale factor. Scale factor is 7. And we'll say Rachel sold 49. Okay, and then we'll circle that because that's the answer. Let's repeat this 7 times because that's the scale factor. So we're going to do 2 and 7. So 2, 4, 6, 8, 10, 12, 14. There's that 7th box. And then 7, let's see, 14, 21, 28. Being able to count by different numbers is a really good skill, comes in handy a lot. Got to know those multiplication tables. All right, there's the one we're after. That adds up to 63, so that's the one we want. And then there's the answer right there. Okay.